Welcome to our channel Ultimate Science Academy. Today we discuss on the topic of vector. In this video we discuss some basics of vector analysis and its application to physics without going in details. A physical quantity in addition to magnitude has specific directions, obeys the law of parallelogram of addition. What is the law of parallelogram of addition? This formula is R is equal to root of a square plus b square plus 2ab cos of theta, and its addition is commutative. This formula is a vector plus b vector equal to b vector plus में a vector. Then and then only it's said to be vector if any of the above condition is not satisfied. The physical quantity cannot be a vector. Velocity, force, weight, momentum, impulse, torque, electric field or temperature gradient are some example of physical quantity which are vectors. It must also be noted that in physics, certain physical quantities such as area, dipole moment, current, densities are defined as vectors with specific directions. For example, to area, the assigned direction is outward, normal to the area, while in case of a dipole moment, it is along the line joining the charges from negative to positive charges. Vectors can be divided into two types: polar vectors and axial vector. In this video, we discuss on the topic of polar vectors, axial vectors, addition of vectors, resolution of vectors into components, multiplication of division of vectors by scalar, scalar product of two vectors, vector product of two vectors, scalar triple products. The polar representation of vectors depend on the polar coordinate systems. R and theta are used to represent vectors. In case of a displacement, these have starting points A and B, and in case of a force, this is the point of applications. What is axial vectors? The axial vectors present rotation effect and always along the axis of rotation in accordance with right hand screw rules. In plane of motions, we see in clockwise rotation the axial vector in downward directions, and in anti-clockwise the axial vector is upward. Angular velocity, torque and angular momentum are some example of physical quantity of axial vectors. Vectors have their own algebra which is different from ordinary algebra. For example, in ordinary algebra we see 3 plus 4 is equal to 7 and A cross of B is equal to B cross of A. And while in vector algebra we see 3 vector plus 4 vector is equal to 1 vector to 7 vectors, and A vector cross of B vector not equal to B vector cross of A vector. Now we discuss some important points in vectors. First, if a vector is rotated through an angle other than multiple of 2 pi, it changes. Second, if a vector is placed, displaced parallel to itself, it does not changes. Here we see A vector, B vector and C vector. These all are equal. This is the translation of a vector parallel to itself. Next, if a frame of reference is translated or rotated, the vector does not changes. Here we see This is the frame of reference. S dash. This is OS. This is O. This is another OS. Next, two vectors are called equal if their magnitudes and directions are same. Negative for vector means a vector of same magnitude but opposite in direction. Here we see a vector and b vector. These are in opposite directions. Next, null vector or zero vector is defined as a vector whose magnitude is zero and direction indeterminate. Next, any vector can be written as a product of unit vector in the direction and magnitude of a given vector. Here we see a vector is equal to a n vector. Now n vector is equal to a vector by a. Next, unit vectors along x, y and z axes are usually represented by I vector, j vector and k vector respectively. So if the coordinate of a points are x, y, z, then position vectors are r vector equal to I vector x plus j vector y plus k vector z. Then r square is equal to x square plus y square plus z square. Next, angle between two vectors means smaller of the two angles between the vectors when they are placed tail to tail by displacing either of the vector parallel to itself. Next, angle between collinear vectors is always 0 and 180 degree. What is the addition of vectors? Vector addition finds its application in physical quantities where vectors are used to represent velocity, displacement and accelerations. Here we see in figure the sum a vector plus b vector is a vector r vector drawn from tail of a to the head of a b. That is a vector plus b vector is equal to r vector. As the figure formed is a triangle, this method is also called triangle method of addition of a vectors. The addition of two vectors may also be understood by the law of parallelograms. According to this law, if two vector p vector and q vector are represented by two adjacent sides of a parallelogram, both pointing outward as shown in figure, then the diagonal drawn through the intersection of the two vectors represent the resultant. Here that if q vector is displaced from position AD to BC by displacing it parallel to itself, this method becomes equivalent to the triangle method. In case of addition of a two vector by parallelogram method, the magnitude of resultant will be given by this formula AC square is equal to AE square plus में EC square. Then we get formula resultant R square is equal to P bracket P plus में Q cos theta की whole square plus Q sin theta की whole square. Now R is equal to root of P square plus Q square plus 2PQ cos theta. Then we find tangent of phi This is CE by AE. Now formula is q sin theta by p plus q cos of theta. Now we get phi is equal to tangent inverse q sin theta by p plus q cos of theta. So this is, we get formula by parallelogram law of vectors. In addition of vector, some points to be noted. First, vector are added geometrically and not algebraically. Vector whose resultant have to be calculated behave independently. Vector addition is nothing but finding the resultant of a number of vector acting on a body. Vector addition is commutative. This means that the resultant vector is independent of the order of vectors. Next, to the vector, only a vector of some type can be added and the resultant is a vector of the same type. For example, to a force, only a force and not velocity can be added and the resultant will be a force and not any other physical quantity. Next, vector is commutative. Vector addition is commutative. We also know commutative means p plus में q, p vector plus q vector is equal to q vector plus p vector. Next, vector addition is associative. Means p vector plus q vector plus में r vector bracket of plus equal to p vector plus q vector plus में r vector. So next, r is equal to p root of p square plus p q square plus में 2 p q cos of theta. This is the formula resultant. So r will be maximum and theta cos theta is equal to maximum is equal to 1. That is theta is equal to 0 degree. So we can say that vectors are like or parallel. The resultant will be minimum if cos theta is minimum. Means theta is equal to 180 degree. Means cos theta is equal to 1. So vectors are antiparallel. If the vectors if the vectors p and q are orthogonal, means theta is equal to 90 degree. Then theta is equal to 90 degree, cos 90 is equal to 0. So resultant होगा root of p square plus q square. Next, the resultant of the two vectors can have any value from p minus q to p plus q depending on the angle between them, and the magnitude of the resultant decreases as theta increases from 0 to 180 degree. Next, r minimum when then r is equal to p minus q. If p not equal to q, r minimum is not equal to 0. That is, resultant of two vector of unequal magnitude can never be 0. Next, so minimum number of unequal vectors whose sum can be 0 is 3. We can say that in case of 3 vectors, the resultant may be 0, and it will be only when one vector is equal to the negative of the sum of the remaining two vectors. This means vectors are coplanar. Next, the resultant of 3 non-coplanar vectors can never be 0, or the minimum number of non-coplanar vectors whose sum can be 0 is 4. Now, what is the polygon law of vectors? So, By the application of a law of polygons of vectors, addition of any numbers of vector is possible. If three or more vectors can be represented by the sides of a closed polygon taken in the order, the resultant of the vectors must be 0. So we can say that by the polygons law of vector, addition of more than 3 vectors and more vectors are possible. Additions of 3 or more vectors are possible. So this is the polygon. In this figure we see a vector, b vector, c vector, d vector. This is the a vector, b vector, c vector, d vector. Now resultant is equal to r vector is equal to a vector plus b vector plus c vector plus d vector. So the coplanarity of a vector is not necessary for the validity of polygon law. So this is the polygon law of vectors. Simply, we also discuss on the subtraction of a vectors from a vector is the addition of inactive vectors. Means p minus q is equal to p vector plus minus of q vector. As shown in this equations. Now we can see this figure. Here p vector, q vector. This is p plus q vector. Now we see subtractions of a vector from a vector. This figure shown by this. Here we see this is p vector, this is minus q vector. So the resultant is p vector minus q vector. So we see here this is angle theta and this is 180 degree minus theta. So while when we put this in the resultant formula, we get p square plus q square minus 2 p q cos of theta theta root of p square plus q square minus 2 p q cos of theta. Here we see cos of theta, cos of 180 minus theta is equal to minus cos of theta. So subtraction is not commutative, that is p minus q not equal to q minus p. And change in a vector physical quantity means subtraction of initial vector from the final vector. So we also discuss this subtraction of vectors from a vectors, and we also discuss property related to vector additions are associative properties, commutative properties. We know that associative property means p vector plus q vector plus r vectors is equal to bracket of p vector plus q vector bracket 1 plus r vector, and by commutative property p vector plus q vector is equal to q vector plus p vector. Now we discuss on the topic of resolution of vector into components. So in which firstly we consider a vector r vector in xy plane as shown in figure. This figure, if we draw orthogonal vector rx vector and ry vector along x and y axis respectively, then by law of vector additions r vector equal to rx vector plus में ry vector. Now as for any vector, a vector equal to an vector, rx vector is equal to I vector rx, and ry vector is equal to j vector ry. Then r vector is equal to I vector rx plus j vector ry. So we can say r rx is equal to r cos of theta and ry is equal to r sin of theta, since r and theta usually gives the magnitude of the components of r vector along x and y axis. That once a vector is resolved into a component, the component themselves can be used to specify the vector. The magnitude of a vector r vector is obtained by squaring this formula, and direction of the vector r vector is obtained by this. Tangent theta is equal to ry over rx. So we find theta is equal to tangent inverse ry over rx. If we discuss in the 3 dimensions, then a vector r vector in components along x, y, z axis can be written as OP vector is equal to OB vector plus BP vector is equal to OA plus AB plus BP. This is A. So r vector is equal to rx vector plus ry vector plus rz vector is equal to I vector rx plus j vector ry plus k vector rz. So we get formula r is equal to root of rx square plus ry square plus rz square. So we define, so we get cos theta x is equal to rx over r, cos theta y is equal to ry over r, and cos theta z is equal to rz over r. This is also called the direction cosines of a vector. So now this is the resolution of a vectors into the components. Now we discuss multiplication or division of a vector by a scalar. One can multiply a vector by a scalar, a number. Suppose that we are given a vector v vector and a scalar a vector, scalar a. The multiplication a v vector is defined to be new vector say w vector whose component are the component of v vector multiplied by a. So we can return this formula like this. We can also return a v vector is equal to av n vector, and a v vector over a is equal to v over a n vector. So in multiplication of a vector by a scalar, the magnitude becomes a times while direction remains the same. In division of a vector by a scalar, the magnitude becomes 1 by a times and direction remains the same. We can also write this formula like this. Now we discuss on the scalar product of two vectors. So scalar product or dot product of a two vectors is defined as the product of magnitude of two vectors with cosines of angle between them, cosines angle. See in figure. Them, and then the scalar product written as a vector dot of b vector is equal to ab cos of theta. So this is the scalar product of two vectors. Now we discuss some properties of scalar product of vectors. First, it is commutative, means a vector dot of b vector is equal to b vector dot of a vector. This is, it is commutative. And second, it is distributive. This formula is this: a vector dot of b vector plus c vector equal to a vector dot of b vector plus a vector c vector. This formula is like this. Next, it is always scalar, which is positive if angle between them
between the vectors is acute, means 90, less than 90 degree, and negative if angle between them is obtuse, means theta varies from 90 to 180 degree. Next, we can also find theta values from this. We can see here a vector, b vector. Here the angle is theta, and we can also find an theta value from this. Theta is equal to cos inverse a vector b vector by ab. So next, scalar product two vectors will be maximum when cos theta is equal to uh, 1, means theta is equal to 0 degree. When theta is equal to 0 uh, degree, then its maximum, means a vector dot of b vector is equal to ab. When theta is equal to 90 degree, then its minimum, means a vector dot of b vector is equal to 0. If the scalar product two non-zero vectors vanishes, the vectors are orthogonal. Next, the scalar product of vector by itself termed as a self-dot products. So we can also say a square. We can also say a square is equal to a vector dot of a vector is equal to a a cos theta is equal to a square. A square. So value of a is equal to root of a vector. In case of unit vector, we can also see here n vector. This is, we can also see n vector dot of n vector is equal to 1 into 1 into cos 0 is equal to 1. And next, n vector dot of n vector is equal to I vector dot of I vector, j vector dot of j vector is equal to k vector dot of k vector is equal to 1. So this is in a case of unit vector. If in case of orthogonal unit vector, I, j, k vectors, uh, we can also say I vector dot of j vector is equal to j vector dot of k vector is equal to k vector dot of I vector is equal to 0, because in which cos theta is 0, means theta is 90 degree. So now we considers in term of a components. If we see in term of a component, we see here this AB, A vector dot of B vector is equal to I vector AX plus J vector AY plus K vector AZ dot of I vector BX plus J vector BY plus K vector BZ. So we can also say A vector dot of B vector is equal to AX BX plus AY BY plus AZ BZ. So this is the some properties of the scalar product two vectors. We can also uh, uh, give some example. Firstly, we say work W is equal to F vector dot of S vector. Second, we say power is equal to F vector dot of V vector. Third, we can also say flux, magnetic flux is equal to integration of B vector dot of TS vector. We can also say current I is equal to integration of j vector dot of ds vector. We can also consider in which potential energy of dipole u. So these are the all the some properties and example of the scalar product of two vectors. Now we discuss cross product of two vectors. The vector product or cross product two vector is defined as a vector having a magnitude equal to the product of a magnitude of two vectors with the sign of angle between them and direction perpendicular to the plane uh, uh, plane containing the two vectors in accordance with right hand screw rule. So here we see in this figure. So C vector is equal to A vector cross of B vector. Then C vector is equal to A vector cross of B vector is equal to AB sine of theta n vector. So the direction of A vector, A vector, direction of A vector cross of B vector, that is C, is perpendicular to the plane containing vector A vector and B vector, and in the sense of advance of a right hand screw rotated from A vector to the B vector through the smaller angle between them. Thus, if a right hand screw rule whose axis is perpendicular to the plane framed by the A vector and B vector is rotated from A to B through the smaller angle between them, then the direction of advancement of a screw gives the direction of A vector cross of B vector. So this is the vector products of the two vectors. We also discuss some properties here. First, we discuss vector product of two vectors is always a vector perpendicular to the plane containing the two vectors. Second, vector product two vector is not a commutative. Commutative means A vector cross of B vector not equal to B vector cross of A vector. Second is vector product uh, is distributive. This formula is this distributive. A vector cross of B vector plus C vector is equal to A vector cross of B vector plus A vector plus cross of C vector. Second is a vector product two vectors uh, formalize this, we also know. Then we also find the value of theta. Uh, so theta equal to sine inverse magnitude of A vector cross of B vector and magnitude of A vector by theta is equal to sine inverse magnitude of A vector cross of B vector by a magnitude of A vector and magnitude of B vector. So next property is the vector product two vector will be maximum and theta is equal to 90 degree, and vector product of two vector is minimum and theta is equal to 0 degree. Minimum value uh, uh, is 0 degree. So self-proposed product of two vectors is also vanishes. We see here A vector cross of A vector is equal to 0. So in case of unit vector, we can say n vector cross of n vector is equal to 0. So I vector cross of I vector is equal to j vector cross of j is equal to k vector cross of k is equal to 0 degree. And in case of orthogonal vector, see here we see uh, in accordance with the right hand screw rule, we can say I vector cross of j vector is equal to k vector, j vector cross of k vector is equal to I vector, k vector cross of I vector is equal to j vector. It also cross product is not a commutative. So j vector cross of I vector is equal to minus k vector, and we also see k vector cross of j vector is equal to minus I vector, and I vector cross of k vector is equal to minus j vector. And in term of components, we can say A vector cross of B vector is equal to I vector j vector. We can write here this like this. So this meaning is A vector cross of B vector equal to I vector ay bz minus az by plus j vector az bx minus ax bz plus k vector bracket ax by minus ay bx. We can see here this this formula is this. So this is the properties. These all are the properties of vector product of two vectors. We already discussed the properties of vector product two vectors. We can say it is always vector plane containing the two vector. It is not a commutative. It is distributive. The vector product is maximum when theta is equal to 1, and self product produce null vector. So we can also discuss on some example. First, we can say, since vector product to vector is a vector, many vector physical quantity like torque, angular momentum, velocity, force on a charge, on a moving charge in magnetic field can be expressed as a vector product to vectors. So we can see torque. This formula is this torque r cross of f vector, r cross of f vector, and we can also see angular momentum. Sorry, this is the velocity. This is the velocity. And formula of angular momentum is L is equal to r vector cross of v vector. We can also from a velocity, also from those polygon pointing vectors. So we also this is the formula of force on charge particle क्या moving with velocity v vector in a magnetic field b vector. So this is the formula, and we also see the example torque on a dipole in a field. So this is the formula. So this is the all the example of vector. Now we discuss scalar triple product. Here we see a vector dot of b vector cross of c vector. It is a scalar, and so it is a scalar triple product from the diagram. This diagram, in which we see a cos theta. This is a cos of theta, and this is the figure. Now we can say from this diagram b vector cross of c vector is equal to bc sine of phi. Sine of phi, a vector dot of b vector cross of c vector is equal to a cos of theta. bc sine of phi. bc sine of phi. This is phi. Sine of phi. This is sine of phi. Sine of phi a. This is sine of phi. Sine of phi. So this is the volume of paralleloid. So it represents the volume of a paralleloid represented by edges A, B, C. And next, a vector dot of B vector cos of C vector is equal to 0 implies that vector are coplanar. This is coplanar. Next, in scalar triple product, dot and cross can be interchanged provided that their cyclic order is maintained. This is the important point. In component form, we can also write a vector dot of b vector, a vector dot of b vector cross of c vector is equal to this, like this, and 4 points a b c d are, if next point, sorry, if a b c d uh, are the 4 points and these all are coplanar, then a vector ab vector dot of bc vector cross of cd vector is equal to 0. So this is the scalar triple products of two uh, scalar triple products, and we also see here this is, oh sorry, b's magnitude of b vector cross of c vector is the area of parallelogram with sides b and c, and value of n vector is like this. So this is the scalar triple products. Thank you so much for watching this video. Please subscribe and like this video.